Okay, students, let us discuss 25th dated physics assignment based on kinetic theory of gases. Now have a look on the first problem in the assignment. Which of the following statement is about kinetic theory of gas is wrong? They given four options. Out of them, the molecules continuously in that is inelastic collision. You know very well the collision between the molecules is always elastic, but they have given collision between the molecules of kinetic theory of gas is inelastic, which is wrong. Hence, second option is wrong for the first question. And have a look on the second question. If the gas molecules undergo inelastic collision which with the walls of the container, then what will happen? So everyone knows that neither the temperature nor pressure will change, only momentum will change. So for second question, neither temperature nor pressure changes, only momentum changes. That's why you can take out of the four options, third option is correct. Similarly, you can have a look on question number 3. So the third question clearly explains that the temperature of a gas is raised while its volume remains constant. So the pressure exerted by the gas on the walls of the container increases because its molecules sticks the walls more often with higher velocities. That is the reason why you should have that one. Next, have a look on question number 4. Fourth question clearly gives that gas at a pressure P0 is contained in a vessel. So let us take a vessel which has a pressure P0 contained in a vessel. If masses of all the molecules are halved and their speeds are doubled, so m1 is m, mass becomes half, m2 m by 2, and speed becomes double. v1 is equal to v, v2 is equal to 2v. Then they ask to find their speeds are double, the resulting pressure P will be equal to. Now what is the new pressure? P2 question mark. Now we know very well the relation between pressure and this one, you can take that P is directly proportional to M and V square. Whenever you can substitute P1 by P2 is equal to M1 by M2, M1 is M, M2 is M by 2, V1 is V, V2 is equal to 2V whole square. By simplification all those things, you are going to get new pressure P2 is equal to 2P0. So this relation already we discussed in the class. That is nothing but the relation between pressure, density and volume. So we know that density is equal to mass by volume. Then you can have a relation P is proportional to M into V square. P1 by P2 is equal to M1 by M2 into V1 by V2 whole square. By substituting those values, you are going to get the relation as P2 is equal to 2P0. Next, have a look on the question number 5. Question number 5, fifth question. If K is the Boltzmann constant, K is the Boltzmann constant, and they given as K is the Boltzmann constant, the average kinetic energy of a gas molecule at absolute temperature is, so Ke average. We know very well already by the kinetic theory of interpretation, K is equal to 3 by 2 PV or 3 by 2 KT. Because PV is equal to LRT, you can write in the terms of Boltzmann constant K is equal to 3 by 2 KT. Hence we can say that this option is correct. Fourth option is correct. Next, have a look on question number 6. E0 and EK representative E0 and EK represents the kinetic energy of oxygen as well as the kinetic energy of hydrogen. E0 and EH represents the kinetic energy of oxygen and kinetic energy of the hydrogen. So E0 represents for oxygen, this is for hydrogen. Then the question is that energy of molecule of the oxygen and hydrogen, if the two gases are at the same temperature, whenever two gases are at the same temperature, T is equal to constant. Then the question is that which of the following statements are true? Statement is true. Whenever it is very clear that KE is directly proportional to absolute temperature. KE is directly proportional to absolute temperature. If absolute temperature is constant, then kinetic energy of also constant. Hence we can say that both they have given at the same temperature. If temperature is constant, kinetic energy is also constant. Hence we can say that energy of oxygen, kinetic energy due to oxygen is equal to kinetic energy due to hydrogen. This option can be correct. Next, have a look on question number 7. Choose the correct statement from the following. So they have given different statements. We know already the kinetic theory of interpretation based on the concept. The average kinetic energy of a molecule of any gas is same at the same temperature. That's what I explained just now. So kinetic energy is only depends on absolute temperature. Remaining three they have given for different relation cannot be. It is depends on kinetic theory is directly proportional to absolute temperature as per kinetic theory of gases. Hence we can say that first option is correct for 7th one also because of the given statement. Next 8th one. Choose the only correct statement from the following. First question, first option. The pressure of a gas is equal to total kinetic energy of the molecules in unit volume of the gas. Cannot be. Second one. The product of pressure and volume of a gas is always constant. Cannot be ruled. If only temperature is constant, then only PV is equal to constant. Next third option. The average kinetic energy of the molecules of the gas is proportional to absolute temperature. So entire this chapter depends on the condition is that the kinetic energy is directly proportional to absolute temperature. Hence we must notice that the kinetic energy is proportional to absolute temperature. So we can feel the third option is correct and also have a look on the fourth option. The average kinetic energy of a molecules of a gas is proportional to square root of absolute temperature. No, it is directly proportional to absolute temperature. Hence for question number 8, third option is perfectly correct. Now have a look on question number 9. Ninth question. Question number 9. Now see, ninth question. Choose the correct statement when the temperature of the gas is increased. The kinetic energy of the molecules also increases. The first option. Potential energy not depends. The potential energy decreases not depends. The potential energy. Only kinetic interpretation of theory states that the kinetic energy is directly proportional to absolute temperature. Hence, if absolute temperature increases, then kinetic energy is also increases. Neither potential, only depends on kinetic energy. Next, have a look on the 10th question. 10th question. At absolute zero temperature, the kinetic energy of the gas molecules already we discussed. Gas, every molecule, even though it is ideal gas, can have its own orientation of collision. But whenever it comes to absolute zero, is nothing but 0 Kelvin, but not 0 degrees Celsius. At 0 Kelvin, the molecules of the motion gets seized. Whenever the motion of the molecules gets seized, then once they cannot have collision. If they cannot have collision, temperature is zero as per the kinetic theory of interpretation. Kinetic theory is directly proportional to absolute temperature. Hence, if T is equal to 0, then kinetic energy is also equals to 0. No second thought. Next, have a look on question number 11, graph. The graph which represents the variation of mean kinetic energy of the molecules with the temperature. Everyone knew that. The kinetic energy K is proportional to T. Whenever it has some constant, then you can say that the relation between kinetic energy and temperature is a straight line. Hence, you can go for the third option. Next, have a look on question number 11. This is graph is nothing but this is 11th question. Graph. Next, question number 12. The question is that some gas at 300 Kelvin is enclosed in a container. They have taken a container. Inside some gas. The temperature is equal to 300 Kelvin. It is enclosed in a container. 300 Kelvin. Right? Yes. Now, the container placed on a fast moving train. Now, this entire container is placed on a train. That it is a train. Has different compartments. Let here the T system. Now, whenever it is placed in a compartment of the train. If the train moving, the options let us have a look that motion, the temperature of the gas raises above 300. Point number 2, it is fall below 300, remains unchanged and becomes unsteady. So it is very clear that it remains unchanged. The reason being that you know very well, kinetic theory of gas of interpretation is directly proportional to absolute temperature. Whenever if the gas molecules, because they are moving it constant, then molecules will have the same velocity. If velocity remains the same kinetic energy, then kinetic energy is directly proportional to absolute temperature. Hence you can't say that temperature neither increases nor decreases. The temperature always remains the same, as being a microscopic property remains same. So this is the way, because the net average becomes neglected. Let's have a look on question number 13. At which of the following temperature at which of the following temperature would the molecules of a gas have twice the average kinetic energy having 20 degrees Celsius? If they given initial temperature 20 degrees Celsius, you must convert in this kinetic theory of plus 273. T1 is equal to 293. Ke1 is equal to K. You can say Ke1 is equal to K. Now at what temperature? T2 is equal to question mark, it is in Kelvin. The kinetic energy becomes double. To make it kinetic energy doubles, what should be the temperature? Everyone knows that K is directly proportional to T. K1 by K2 is equal to T1 by T2. Now K1 is nothing but K by K2 is 2K is equal to T1 is nothing but 293 by T2 is nothing but we should find. Now KK gets cancelled. T2 is equal to 293 into 2, that is equal to, you are going to get that net answer. Then you are going to be converting to Kelvin to Celsius, it will become 313 degrees Celsius. So this option is correct. Based on only the thing is, we know very well kinetic energy is directly proportional to absolute temperature. Next, have a look on problem number 14. 14th problem. This is the most important problem. It seems to be lengthy, but problem is very direct. 14th problem. A given graph gives variation of PV by T. PV by T versus temperature. Now you can take a graph which along x-axis they given PV by T. Y-axis, along x-axis they have given absolute temperature. With respect to the pressure they given. Yeah. Now they have given two slopes. One is this temperature T1, this is the temperature T2. This is PV by T versus P graph as per the given figure. Now the question is, if the density of oxygen is 1.427, density they given 1.427 of oxygen O2. 1 gram they given, m is equal to 1 gram and molecular weight is equal to 32. So whenever they have given oxygen molecular weight is 32, they given 1 gram of oxygen, m is equal to 1 gram. Then the question is the value of PV by T and relation between T1 and T2. First let us find the value of PV by T. We know very well PV is equal to N or capital T. Now we can say that P is equal to N or T by V. P is equal to, we know very well, they ask you to find which value? They ask you to find PV by T value. What is the value of PV by T? PV by T is equal to question mark. From this we can write that PV divided by capital T is equal to NR. But as per ideal gas equation, we know the relation between mole and molecule. N is equal to small m by capital M. So small m is equal to, that is 1 gram of oxygen by capital molecular weight is 32. By using the relation PV by T is equal to N small m by capital M 1 by 32 into R. Now by simplifying that, you can have a final value. PV by T is equal to R by 32, that is equal to 8.314 by 32. It nearly 1 by 4, which leads the value 0.256. So hence we can say that PV by T is equal to 0.256. And they are even asked to find the relation between absolute temperature T1 and T2. We know very well, ideal gas, real gas will act as an ideal gas at low pressure and high temperature. So this is perfect ideal gas. Hence from the graph it is clear that T1 is greater than T2. Hence fourth option is correct. PV by T is 0.256 and temperature T1 is greater than T2. So fourth option is correct for the given question. Don't panic by seeing these graph values, only the graph they have clearly given to find PV by T as per the ideal gas equation. We have concluded the problem. And have a look on the last problem, 15th problem. 15th problem. 15th. Diatomic gas molecules like hydrogen have energies due to both translation as well as rotational motion. From the equation, kinetic theory, PV is equal to 2 by 3 KE. Then they ask you to find which of the following has to be correct. The total energy per unit volume, only translational part of energy, because rotation energy is very small compared to the translation cannot be. Only the translation part of the energy, because during the collision with one pressure relates the change in leg momentum. Yes, whenever the molecules can have collision with the walls, then only their kinetic energy relates. Hence from that you can say that PV is equal to 2 by 3 KE. This relation we are going to get whenever the molecules hits the walls, then during collision momentum changes, which causes change in momentum by time force causes pressure and kinetic energy relation. So you can say that the third option is correct for the given question. So thank you students, these are the assignments what we can have the 15 questions. Thank you very much.